In this video, we're going to learn about congruence and triangles. Let's look at these two red triangles here. If I label these as triangle A, B, C, D, E, F, and we say that these two triangles are exactly the same, and that's when we say they're congruent. And when we say that they're congruent, we mean their corresponding angles, meaning angle A and angle D are congruent, angle C and angle F are congruent, and angle E and angle B are congruent. So there are three pairs of congruent triangles. Also notice that AB and DE are congruent, BC and EF are congruent, and AC and DF, the longest sides, are congruent as well. So in this case, we call these two triangles congruent triangles. So the way we write it is triangle ABC is congruent to triangle DEF. And when that happens, we have three angles. Angle A and angle D are congruent, and angle B and angle E are congruent, and angle C and angle F are congruent, as well as three congruent sides. AB and DE are congruent, and BC and EF are congruent, and AC and DF are congruent. Okay, now notice that these are my corresponding parts. These angles are my corresponding parts, and these sides are my corresponding parts. So in other words, angle A, the corresponding part for angle A is angle D. For angle B, its corresponding parts is angle E. For angle C, the corresponding part is angle F. So congruent figures, they all, we say that figures, triangles or rectangles are congruent if all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. That's really important. Let's look at a counterexample. In the blue triangles, notice that I'm going to label the big triangle as my angle ABC. And small triangle, I label it DEF. Notice that angle A and angle D are congruent. Angle C and angle F are congruent. If you measure it, angle B and angle E are also congruent. But clearly, its corresponding sides are not congruent. AB is larger and longer than DE. And therefore, these two triangles, ABC and DEF, are not congruent triangles. Their angles are congruent, but the triangles are not congruent, meaning they don't have the same size and same shape. Okay? Here's an example. Given that triangle JKL and SRT are congruent, list all corresponding sides and corresponding parts. Notice how the sequence they label these two triangles. It's really important that when you write about the congruent triangles, here's a congruent sign. So they started with angle J, and the corresponding angle for J is angle S. So J and S are congruent. And then K, angle K, the right angle, and angle R are congruent. And angle L and angle T are congruent. Okay? If you write something like, in this example, if you write JLK is congruent to triangle SRT. You're telling me that angle angle L and angle R are congruent, and clearly angle L and angle R are not congruent because R is 90 degrees and L here is less than 90 degrees. So just be very mindful about the sequence when you write the triangles. So now I have two congruent triangles, therefore I can draw the conclusion that clearly angle K and angle R are congruent because they're both 90 degrees. Angle J and angle S are congruent because they're matching pairs. And angle L and angle T are congruent. In addition to the angles, the three sides, LR and TR, is the shorter legs, are congruent. Longer legs, JK and SR, are congruent. Finally, the hypotenuse JL and ST are congruent. Right? So that's my three corresponding angles, three corresponding parts are congruent to each other. Make sure you finish this checkpoint on your own. And here's an example 2. The two triangles at the right are congruent. Identify all corresponding parts. It's already labeled for us, so it's really nice. Let's start with the angles. I have angle A is corresponding with angle F. They're congruent. Angle C, the one with two markers there. Oops. Angle C and angle E are congruent. And finally, angle B and angle D, the largest angle, obtuse angle, are congruent. And then we move on to the sides. It's also labeled with one ticker. It's BC and DE are congruent. And AB and FD are congruent. And AC and FE are congruent. Right? So I think I have covered it all. And so that's A. For B, we have to write a congruent statement. So we learned that if two triangles are congruent, all angles are congruent to their corresponding angles. All three sides are congruent to their corresponding three sides. And now it's the converse of that. Now I know all angles are congruent to their corresponding angles. I know all sides are also congruent to their corresponding sides. Therefore, these two triangles, which is ABC and triangle F, oops, I'm making the mistake telling myself about. Oops. Let me just erase this part. So angle ABC, and this should be triangle FDE are congruent. So that's my congruence statement. ABC and triangle FDE are congruent. Again, making sure that you finish your own summaries before you move on. Here's the third example. PQR is congruent to XYZ, two triangles. Find the length of XZ. Now we know when the two triangles are congruent, PQR is congruent to XYZ. Therefore, all the corresponding side lengths are congruent. So XZ is congruent. XZ is congruent to PR. That's its corresponding sides. And because PR is 10, and XZ, the measure of XZ and PR should be the same, and that's 10. Right? Notice that when I talk about the over here with the congruence That's my bad handwriting. There we go. If the two side lengths are congruent, meaning they have the same length and as well as shape. And over here, when I use the equal sign, notice how my notation changed. I'm talking about the length. Therefore, the bar on top of the XE and the PR disappeared. And that we covered in chapter 2, I believe, before I came. So that's, then that's the first part. The second part is asking us to find the angle measure for Q, which is here. And again, because the two triangles are congruent, so angle Q should be congruent to angle Y. And therefore, their angle measures should equal each other. Again, notice how I differentiate congruent angles versus angle measure. And therefore, because angle measure for Y is 95 degrees, and my final answer for angle measure for Q is also 95 degrees. Okay? Checkpoint, if you don't know how to solve it, ask your friends, ask me. And fourth example, use the two triangles at the right to identify all pairs of corresponding congruent parts. So it's already labeled for us. Let's start with the angles. Angle D and angle G are congruent. And angle DEF is congruent to angle GEF. And angle DFE is congruent to angle GFE. So that's angles. The sides is also marked for us. DF and GF are congruent. And the second one is ED and EG is congruent, right? And then so that's the first part. The second part is asking us determine if the triangles are congruent. If they are congruent, write a congruence statement. Notice that in order for the triangles to be congruent, all three angles have to be congruent, and that we have proved here. And all three sides have to be congruent. Now we have proved two sides, but I don't have the third side. But did you notice the third side is a shared side? And of course, EF has to be congruent to itself, right? So therefore, now I do have three sides. Therefore, I can write my congruent statement. Make sure about your sequence. It's EDF. If you write it this way, you should write the second triangle as EGF. That way, all corresponding angles are in the same location. Okay, finish this follow-up, and then it's our last example. This one is a little bit more complicated. The reason for that is it actually pulls information from chapter 3 that you need to recall. But let's take it slow. Let's see what do we have here. In this diagram, HG and LK are parallel. Interesting. When we have parallel lines, we should be thinking about these theorems concerning that four sets of angles: alternate interior, alternate exterior, corresponding angles, and same side interior. Okay, so I want to highlight that HG is parallel to LK. Determine if these triangles are congruent. So let's see. It seems that it's easier if we start on the sides. I know what's given. KJ is congruent to JH. I know that LK is congruent to GH. And I also know that JL is congruent to JG. So that's three sides. Notice that it doesn't have any information about angles, at least it doesn't seem to have any, so I need to do some observation. First thing first, do you notice that I've got right here, I've got a, my pen doesn't, stylus doesn't do justice there, so I'm just going to do this, okay? So do you notice that I've got a vertical angle there? So if you look carefully, angle LJK and angle GJH, these two are vertical angles right here. And by vertical angle theorem, they must be congruent, right? So that's one pair. Also notice that this is where these information comes in. These two lines are parallel, and you can use HK as a transversal. And when two parallel lines are cut by a transversal, these two angles, the alternate interior angles, should be congruent. So L, if I erase this junk here, see how much I can get. So LKH should be congruent to KHG, and that's my second angle. If 2 out of 3 angles are congruent, the third one has to be congruent because the three interior angles add up to 180. So finally, another way to look at it is because these two parallel lines, this angle and this angle here, which is angle KLG and angle LGH, are also congruent because they are alternate interior angles. So again, 3 angles and 3 side lengths are all congruent to their corresponding parts. Therefore, triangle, be careful with the sequence, LJK is congruent to triangle GJH, and that is my congruence statement right here. That's it for this unit. Oops. Make sure you pause the video and finish all of your checkpoints and follow-up summary. Thank you, guys.